In this video, we'll be graphing the rational function f of x equals x squared plus 5 over x plus 1. The first thing I like to do when I'm graphing a rational function is to find the vertical asymptotes. The vertical asymptotes are those values of x that make the denominator equal 0, because we can't let a denominator equal 0 in any fraction, and a rational function is just a rational expression is just a big fraction. So in this case, the denominator is x plus 1. So that value of x that makes this denominator equal to 0 is negative 1. So we're going to have a vertical asymptote at this value x equals negative 1. Now this dashed blue line is not part of the graph. It's just an imaginary line that I'm putting as a guide there. Next, I'm going to look at let's look at any other asymptotes. Let's take a look at possible horizontal, or in this case, oblique asymptotes. An oblique asymptote is very similar to a horizontal asymptote in that it looks at the graph as x grows very large. So what does the graph look like to the right or to the left as we zoom out very far away? Now, the reason it's different from a horizontal asymptote is that an oblique asymptote is sometimes called a slant asymptote because it's going to have some slant to it. All right, so let's do this. We have to divide the denominator into the numerator, and yes, we have some long division here. Remember that placeholder here, the 0x, because we don't have an x term up in the numerator. So real quickly, we can just jump to this. This is we're going to multiply this x times x plus 1 is x plus x squared plus x. We're going to subtract that, so we get negative x, drop down the positive 5, and now we have a negative 1. So negative 1 times x plus 1 is negative x minus 1, and we'll subtract that, and we get a 6. We're running out of room here, so we get a remainder of plus 6 over our divisor of x plus 1. So here's what's going on. As x grows really big, right here in the denominator, 6 over something really big is like nothing, right? So here's what we're looking at really is x minus 1. So this is the oblique asymptote, is y equals x minus 1. Again, this is not part of the graph. This is just a little visual aid for us. So in the end, to the right and to the left, our graph is going to start to mimic this line. Okay, so we can start to plot some points here. If we know we're going to mimic this line coming in from the left, we might be above or below it. We can plot some points. I know that we're going to be below it, and we're going to then shoot down. We cannot cross that vertical asymptote, so we're going to go like that. And then we can plug in, say, negative 1/2 to see that we're going to start way up high here coming in. And then where are we going to cross this y-axis? Well, the y-axis, or the y-intercept, let's take a little detour here. The y-intercept, that's simply the value when x equals 0. So right all along that y-axis, the x value is 0. So f of 0 equals 0 plus 5 over 0 plus 1. So f of 0 equals just 5. So that our y-intercept is 1, 2, 3, 4, 5. Let's put it right there. And then again, you could certainly plot some points to know exactly how far down this thing goes. But eventually, we do know that it's going to come back up because it's going to follow that oblique asymptote. So that was just a rough sketch there of graphing this rational function. I hope that helps.